Hello everyone. As you know, we are dealing with chemical properties of phenol, and in chemical property, the very first chemical property is acidic nature of phenol. Yesterday we have found the phenols are acidic in nature because they can release H positive ions. We compared it with alcohol and we found phenols are more acidic than alcohol. Reasons yesterday we have discussed in the video. Now we are going to add substituent on phenol and we will check how substituent can affect phenol acidity. The topic is involved for 12th, JEE, NEET and BSc. First, let's understand what is substituent. This is my normal phenol. OH is connected to benzene ring and here we have hydrogens. Now, if at the place of hydrogen we are writing any other functional group, like cyanide I have written, so this cyanide is known as substituent. Why we are calling it substituent? Because it has substituted the hydrogen or it has replaced the hydrogen. This is known as substituent. Another example. This is normal phenol. Suppose here at the place of hydrogen, NO2 group is joined. So this NO2 is known as substituent because it has substituted hydrogen which was present here. So such functional groups which are joined on a benzene ring by replacing hydrogen are known as substituent. Now these substituents definitely affect the acidity of phenol. How? To understand that concept, first we need to understand these four effects: plus I, minus I, plus R and minus R effect of substituent. On phenol. Plus I effect, minus I effect, plus R effect, minus R effect of substituent on phenol. Let's check what they are. In this video, first I will cover plus I and minus I. First of all, I means inductive effect. Inductive effect. Now this effect arises due to electronegativity difference. Electronegativity difference. What is electronegativity? It's a power to attract electrons toward itself, shared pair of electrons toward itself. For example, suppose a molecule is there which is made up of A and B atom, in which A and B are sharing electrons, means covalent bond is there. If B is more electronegative, what will happen? These electrons will shift toward B, little bit toward B. Now B is getting its own electron toward itself as well as A's electron toward itself. So on B, a negative charge will develop. In this condition, we will say B is showing minus I effect. And because A is losing control on its electron, or you can say A is losing its electron, so A will carry same partial positive charge. In this condition, you will say A is showing plus I effect. More electronegativity difference, more will be the minus I and plus I effect. So inductive effect depends directly on electronegativity difference. Electronegativity means the power to attract shared pair of electrons toward itself. It varies atom to atom. In 11th class that concept was. Now how substituent will affect phenol This is phenol. Now in phenol, if here I am joining a substituent cyanide, so first we will check whether it will show minus I effect or plus I effect. As I told you, minus I and plus I effect is decided by electronegativity. This carbon is sp hybridized and this carbon is sp2 hybridized. sp hybridized carbons are more electronegative as compared to sp2. So what will happen? Definitely these electrons will shift toward this carbon. Means this functional group is going to show minus I effect because negative charge will develop as these electrons will move toward cyanide functional group. This carbon will get positive charge. In turns, what it will do? It will start attracting electrons from this carbon like this. In turns, this carbon will start attracting electrons little bit toward itself from oxygen like this. And in turns, oxygen will start attracting electrons from hydrogen, which already it is doing due to higher electronegativity, but this effect will enhance due to cyanide group. Means cyanide is showing minus I effect here, which will affect OH group like this. All the electrons will shift toward that side. Now minus I effect depends on distance also. Minus I plus I, both effects depend on distance. For example, if cyanide group is here, again carbon will attract electrons from this carbon because sp carbon is more electronegative than sp2 carbon. In turns, this carbon will start attracting electrons from this carbon. In turns, this carbon will start attracting electrons from this. In turns, this carbon will start attracting electrons. In turns, this carbon will start attracting electrons from oxygen. And in turn, oxygen will start attracting from electron from hydrogen. But you can check the distance between cyanide and OH group is too much. How many carbons are coming between them? 1, 2, 3, 4. Lot of distance is there. So don't you think this effect will almost diminished or finished up to OH group? Yes, in 11th class we have done I effects are operating only up to third carbon. After that they are going to finish. So here OH group is feeling very less minus I effect due to distance, and here OH group will feel very high minus I effect. High minus I effect because the cyanide is very close to OH. Only how many carbons are there between them? 1 and 2. So cyanide groups are showing minus I effect, which decreases with distance. Similarly, if we take example of plus I effect by the substituent, this is phenol. Suppose I am joining here CH3 group, methyl group. Now in the methyl group, this carbon have what hybridization? sp3. And this carbon have what hybridization? sp2. sp2 carbons are more electronegative than sp3. So electrons will shift toward that side. Means this group is going to show which effect? Plus I effect. Because after movement of electrons, it is getting positive charge. So we will call it plus I effect. This group is showing plus I effect. And obviously, if these electrons will come to that side, these electrons will be pushed to this side because they are feeling repulsion. And obviously, these electrons which are present between carbon and oxygen will feel repulsion and they will be pushed further. And obviously, these electrons will feel repulsion, they will be pushed further like this. Means CH3 group is donating electrons to the phenol and providing electrons up to OH group like this, plus I effect. And also plus I effect depends on distance like minus I effect. If I say CH3 group is here, so obviously Between CH3 group and OH, distance is increased. How many carbons are between them? 1, 2, 3. So effect will be there, plus I effect will be there. But OH group will feel very less of it because the distance is too much. Now this OH group is feeling very less, plus I effect of CH3, and here it is feeling high, plus I effect of CH3. That's it. In this video, we will understand plus I, and we have understood plus I and minus I effect, and it depends on distance. So to check plus I or minus I effect, you just need to compare the electronegativity of the atom which is attached with the benzene ring. Like if I ask to you, on phenol, if I am joining OCH3 group, a substituent, methoxy group it is, will it show plus I effect or minus I effect? The answer is minus I effect. Why? Because as you know, oxygen is more electronegative than this carbon, so it will attract electrons. So that's it. It is showing minus I effect. Another functional group, like suppose here I have NO2 group. So what effect it will show? Minus I or plus I? Depends on electronegativity. Nitrogen is more electronegative than carbon, so it will attract electrons. That's it. It will show minus I effect. And obviously, whether it is minus I effect or whether it is plus I effect, after all, this OH group is going to feel that effect. Less distance, more effect it will feel. More distance, less effect it will feel. That's it. In next video, we will check plus R and minus R. We will understand first these effects, and then I will tell you overall what effect is there on the phenol acidity. One by one, first we will understand the effects, then we will go for actual concept. How these substituents are affecting acidity of the phenol. Thank you very much. In next video, plus R and minus R effect.